The 2JZ. It's an engine known to many as being bulletproof. But what makes this engine so incredibly strong? Today, we're talking about the engineering behind one of the most notorious engines in the tuner community. But first, a quick 95-second history lesson. The story of the 2JZ started in the 70s, back when bell-bottoms were in, and Toyota was trying to compete with Nissan's very successful Z lineup of cars. To accomplish that goal, Toyota took their existing Celica, stretched it out a bit, slapped in a straight 6 from Toyota's M family of engines, and called it the Celica Supra. The Celica Supra didn't sell nearly as well as the Z, so Toyota amped up their game. Over the course of 6 years, the Celica received multiple makeovers and engine developments. Then, just 1 year later in 1986, Toyota made the Supra a standalone model, with the latest and greatest iteration from the M family of engines, codenamed the 7M GTE, a 3-liter turbocharged powerhouse. At this point, the Supra was selling well, and Toyota could have just stopped development and dropped the project, kinda like the Mitsubishi Evo. But Toyota was working quietly behind the scenes, and 4 years later in 1993, they unveiled the work of art that was the Mark IV Supra, complete with a new engine called the 2JZ. The 2JZ was a derivation from the 7M GTE. However, it wasn't bogged down with the many weak points the 7M had. Blown head gaskets, bearing issues, poorly casted cylinder heads, and oil leaks, just to name a few. Because of this, the 2JZ became a common engine choice for tuners and car enthusiasts alike, and it wasn't long before the boundaries of the 2JZ were put to the test. However, it came as a shock to many that the power limits of the 2JZ were far greater than many could have expected. But let's get to the point. What exactly made the 2JZ so strong? The 2JZ GTE came stock with 267 horsepower in Japan, so how are people able to push 800 horsepower, over 3 times stock, with just a couple bolt-on upgrades? The answer, my friends, is in the block. One of the most important factors here is the material Toyota chose to use, cast iron. Cast iron, unlike aluminum, is a very hard alloy with a score of 110 on the Brinell hardness scale, while aluminum is around 60. Hardness is a metric used to determine a material's ability to resist plastic deformation. This basically meaning that a cast iron block is made to handle more stress than an aluminum block before deforming. To sum that all up, it means that a cast iron block can hold more boost than a geometrically equivalent aluminum block.